lesson 6.6. We are looking at a system of linear inequalities. Now, earlier this year, we looked at graphing just an inequality in a coordinate plane. Now we're going to graph our linear inequality in a coordinate plane. We need to make sure we can decide if it should be a solid or dashed line. Hopefully you remember that, and do some shading. You should be able to graph the inequality. You should be able to explain the solution to that inequality is the intersection of the shaded regions. So what we're going to see now is we're going to do systems of graphing, kind of like 6-1, only thing we're going to be shading them. And our shaded regions will overlap. You'll also notice that you should be able to write an inequality that models the situation. So as we are looking at these problems, make sure you take a look at the I can statements to see that you can do those as you are finishing this chapter. So the vocabulary, a system of inequalities is made up of two or more linear inequalities. The solution to that system is any ordered pair that makes that inequality true. Now what you're going to see is that there's going to be infinitely many, whereas when we looked at our solutions to just a system of equations, we only had one solution, no solution, or infinitely many. Now we're going to look at all the points that make it true. You should be able to graph the system of linear inequalities. It is the set of all points that are solutions. The graph of a system is the region where the graph of the individuals overlap. So what if we were graphing the system? Y is less than 2x minus 3. We know our y-intercept is at 0, negative 3. We know that we have a slope of 2 over 1, and it's positive, which means our line has to go up to the right. In the second equation, we want to rewrite that in slope-intercept form, and y is greater than negative 2x plus 2. So again, in this case, our y-intercept would be at 0, 2 is our start point, and our slope is negative, and it's negative 2 over 1, so our line needs to go down. Both cases should be dashed lines. So we're going to graph the first equation. We're starting down at negative 3. As we start down at negative 3, we are going to start and we are going to go up 2 and over 1, and we would shade everything below that because it says it is less than, so we would shade below. Then we're going to go to our second equation, which starts at a positive 2, and we're going to make it a negative 2 slope. So we're going to go down 2 and over 1, and so we want to get these points. Once we've picked our points, we decide if it's a dashed line or solid line. And in this case, it's dashed. We are looking at all the points that are greater, which means above. The green is our answer. So we want to shade it lightly, and then this is our final solution. And again, remember we talked about picking checkpoints. In this case, 0, 0 would make it false. If we want to look for something that's going to easily make that true, we might want to pick this point, like right here, which is located over at 3, 0. And it has to make both situations true. So if we replace x with 3, 3 minus 0, it says is 0, or 6 minus 3, if we replace that, is that going to be greater than 0? Yes. And if we put 2 times 3 is 6, 6 plus 0 is still 6, is that greater than 2? And it makes it true. So it has to work in both cases. What if you're asked to write an equation in an inequality system given a graph? Well, the first thing we want to take a look at is if we are looking at our, it doesn't matter which one, I'm going to look at the solid line. I can tell my y-intercept. So I'm thinking about y. The next thing is because if I'm looking at this one, it looks like the two overlapping areas is the green, which means I have to go above this line. So that means it's greater or equal for the solid line. And now we want to look at our slope. We know that it's down at a minus 1. So we need to figure out our slope. That's what's in front of x. That is our rise over run. So in this case, it looks like I'm going up 1 and over 1. And so I'm going to have 1x. You could have also written it as y is greater or equal to x minus 1. Once we have our first equation, we now want to look at our second equation. If we look at our second equation, we're looking at our y-intercept. Here is 1, 2, 3, 4, 5. Our y-intercept is 5. And this would be a plus 5. And since it's a dashed line and it's shaded below, we're going to say that it is less than. Since it is less than, we now need to figure out our slope. We're going down 1, and it looks like over 2. Does that hold down 1 over 2? Yes. And if we continue that pattern, is it a positive or negative slope? Since it's going down, it should be a negative slope. So as we look at those two lines, trying to figure those out, and now we're looking at those shaded regions. So it talks about what are the things we know. We're shading above. It's a solid line for equal, shaded below, dashed line, and so on. Then we have our two equations. It is now your turn to try it. I would like you to graph this system. We're going to check it tomorrow in class. So make sure you rewrite the second equation in slope-intercept form. Think about the type of lines. Should it be solid or dashed? And make sure you are shading. And then shade really lightly the first two areas, and then when you get the final area, you want to shade that very darkly so that I can tell. If you want to use colored pencils, kind of like they do here, where they have shading below with blue and yellow, and then the green is our overlap, you could do that also. You should write in your two equations. Hopefully this was a lot of review in this lesson, and hopefully these two made sense. If you need to look in your book, use your textbook in 6-6. You could also go to the Pearson Success Net and watch the video and look at their lesson. The last type of problem we're going to talk about is the story problems or the word problems. As we read problem 3, it's talking about time management, which hopefully all of you are doing well with. It says you are planning what to do after school. You can spend at most, keywords, that's helping us to set our inequality, at most 6 hours daily playing basketball and doing homework. You want to spend less than 2 hours playing basketball. You must spend at least an hour and a half of homework. What is the graph showing how you can spend your time? First thing we need to do is think about identifying your variables. So as you fill in your notes, x should be equal, and we are looking at the number of hours that we can play basketball. What is y going to be? Hopefully you're telling us that is now going to be your hours spent doing homework. What are our systems of equation? It says at most 6 hours of basketball. So at most means that x and homework, x plus y is less or equal to 6. X plus y is less or equal to 6. Less than 2 hours of basketball. Well, if basketball is on our x-axis, x is basketball, we are going to write that as x has to be less than 2. At least 1.5 hours of homework. That means we could do more homework, so y is greater or equal to 1.5. So we actually don't even have 2 equations, we have 3 equations that we are looking at. In the first one, we would want to rewrite that in slope-intercept form. So if we are writing that in slope-intercept form, we are going to have y is less or equal to negative x plus 6. Does it make sense for it to be in anything but quadrant 1? It does not. So thus, we are only using quadrant 1 in our graphs. Be careful. Some of you last time when we graphed story problems, you tried to tell me we could have solutions in quadrant 2, 3, and 4. We can't do that, only quadrant 1. So if x is less than, if we are looking at that, less than 2, that means we have a dashed line and everything shaded to the left of that. What about for our equation that is written in y less or equal to negative x plus 6? Starting point 6, slope is negative 1, we would get all our points. We would again be shading below. So if we kind of wanted to shade this with our lines, this would be our blue line, less than that. If we were looking at x, I might show it this way. And then the last one says that y has to be greater or equal to 1/2. So at this point, we're kind of thinking that it would have been in this whole trapezoidal area. But now, because it also has to be greater or equal to 1.5 hours, we are also shading all above this. So we're looking where do these 3 areas overlap, and that's the green area. It is a solid line here, it is a dashed line because of the less than, and it is a solid line, and it includes all of those hours. We are not going to have points because in time we could have 1/2 hour and 1/4 of an hour as you're looking at those. It's now your turn to try it. The question says you want to build a fence for your dog to run. You want the run to be at least 10 feet wide. The run can be at most 50 feet long, and you have 126 feet of fence. What is the graph showing the possible dimensions? Now, hint, you're going to have 3 equations, and the last one deals with this, you have 126. That is your perimeter. And if it helps you to draw a picture to get this, you might want to use, instead of x and y, you can use x for width, y for length. Think about your equation for perimeter, and then you might want to solve it in terms of y. If we think of y as the length, then you might want to decide, well, which one is the run for, and then the at most. So as you are looking at those on that rectangular, you want it to run at least 10 feet wide, so at least 10 feet wide. The y is going to be our x, and you want it to be at most 50 feet long. The long is going to be your y. Good luck writing your equations. You should have 3 of them. Think about each of those, and we will look at them tomorrow. If you need to look again at the example, go back to that. Go to Pearson SuccessNet. Go to your textbook. I have no doubt that you guys will be able to do this. Thanks. See you tomorrow in class.